Let's take a quick look at the rules for significant figures. We want to be able to tell when we look at a measurement how many significant digits that measurement has, and don't forget every measurement should have units associated with it. Rule number 1 says all non-zero digits are significant. Alright, if you don't have any zeros in your measurement, then all of those digits are significant. So if you see a number like, say, 4.273 grams, since there are no zeros, all of those digits are significant, so this number would have 4 significant figures. And you'll see that we're mostly looking at zeros to tell how many significant digits are in a measurement. Zeros between non-zero digits are significant is rule number 2. If you see a number or a measurement like this, let's say 52.307 liters, then this number would have 5 significant figures since the zero is between non-zero digits. Now things start to get a little more interesting. Rule number 3 says trailing zeros are only significant if a decimal point is present. So you might see a number like this, let's say 240 liters. This number only has 2 significant figures since there is no decimal point. So the trailing zero is not significant in that measurement. But if you saw that measurement and there was a decimal point present like this, then you would have 3 significant figures. Or you may see this measurement where you've got trailing zeros to the right of the decimal point. In that case, this measurement has 5 significant figures. And to make things a little less ambiguous, you could always write these in scientific notation. When you write a number in scientific notation, you take all of the significant digits, put a decimal place after the first one, and express it as a power of 10. So this would be 2.4 times 10 to the 2 liters. This has 3 significant digits, so place a decimal point after the first one and express it as a power of 10. 2.4 times 10 to the 2 liters. And since this number has 5, you would include all significant digits when you write it in scientific notation. So 2.4000 times 10 to the 2 liters. Rule number 4 says leading zeros are not significant. And this is one where students usually forget about this rule, so don't forget about the leading zeros. They're considered placeholders. They just tell you relative to the decimal point where your measurement is. If you see a number that looks like this, 0.000725503 meters, then all of those leading zeros are not significant. And this measurement would have 1, 2, 3, 4, 5 significant digits. And you could always express this in scientific notation. You could write 7.2503 times 10 to the minus 1, 2, 3, 4, 5 meters. The last rule of significant digits says that counted or exact numbers and constants do not follow the rules of significant figures. This is something like if you have a dozen pencils, then that's a counted number. There are no decimal points. It's not a measurement. It's an exact number. So we don't need to include the number of significant digits. We don't care about them. Universal constants like the speed of light, c, is 3 times 10 to the 8 meters per second, right? That's a universal constant. This number has been measured out to as many significant digits as you need. So you could look this number up and you might find something like 2.99798 times 10 to the 8 meters per second, right? It's got as many or as few significant digits as you need. So we don't consider the rules of significant digits when we're working with counted numbers or universal constants.